Dear student, I welcome to you in my YouTube channel KB Physics 11. As you know, I have already discussed about circular motion and uniform circular motion. This video is related to multiple choice question based on circular motion. So you must remain up to end in this video so that you can able to understand the numerical problem, conceptual question based on circular motion. So let us start. This is our first question. Here in this question, a particle is moving on a circular path makes 600 rpm. In how much time it will complete one revolution? So here it is given 600 rpm. So remember, this is the angular frequency of the particle performing circular motion. Angular frequency. So convert it into revolution per second because it is in revolution per minute. So frequency nu is equal to 600 rpm is equal to 600 upon 60 rps. So this is 10 rps. And we have to find out the time period. So time period can be easily calculated by this relation t is equal to 1 upon frequency. So 1 upon 10, that is 0.1 second. This is the time taken by the particle to complete one revolution. Now second question. Second question is based on concept. That is, a particle moves with constant angular velocity in a circle. During the motion, its energy is constant, momentum is constant, energy and momentum both are constant or none of above. So here, as we know, in uniform circular motion, angular velocity is constant. And the magnitude of linear velocity is also constant. The direction of the velocity keep on changing. So the magnitude of velocity remains constant in uniform circular motion. Because this is the case of uniform circular motion, here angular velocity is constant given. So when magnitude of velocity is constant, it means its energy will remain constant. So our first option is correct. About second option, momentum is constant. Momentum is a vector quantity. So momentum cannot remain constant because direction of the motion, that is the direction of the velocity, is changing continuously when the particle performs circular motion. Similarly, in option C, again momentum is coming. So this option cannot be taken as correct. So our first option is correct. Next, question number 3. This question is also related to very simple concept. The question is, an object is moving in a circle of radius 100 meter with a constant speed 31.4 meter per second. What is the average speed for one complete revolution? Here, the speed is constant. Whenever the speed is constant, then the average speed calculated for any time duration will come out equal to the speed given. When speed is constant in any type of motion, the average speed will be equal to the given speed, given constant speed. So our answer is 31.4 meter per second. Next question. A stone is tied to one end of the rope and rotated in circular motion. If string is suddenly break, then the stone travels. This is the case. Suppose this is the stone here, this is the rope, And as we know, the direction of the motion of this stone keep on changing continuously because it is performing circular motion, and direction of the velocity is always along the tangent drawn at any point on the circular path. Suppose if the stone is here, then this is the direction of the motion, that is the direction of the velocity of the stone. When it reaches here, this is the direction of velocity. Here, this is the direction of velocity. Any direction of velocity is always along the tangent drawn at any point on the circular path. Whenever this string is break up, therefore the stone will fly in the direction of the motion, that is along the tangential direction, because the direction of velocity is along the tangent drawn at any point. Therefore, the option D is correct. What about the other option? In first option, it is given perpendicular direction. Perpendicular direction means option is not very clear. To what perpendicular? It is not given. So this option cannot be taken as correct. So in the direction of the centrifugal force always act away from the center of circular path. This is the direction of centrifugal force. So the object, that is the stone, will not fly off in this direction. In third option, towards the centripetal force act towards the center of the circular path. So the particle, that is the stone, will not move towards the center because the direction of the motion is along the tangent. So it will not change its direction of the motion by itself when string is break up. So D option is correct. Next. Question number, this is question number 5. Here is a simple numerical. A particle is moving along the circular path of radius 5 meter with uniform speed 5 meter per second. What will be the average acceleration when the particle complete half revolution? Average acceleration we have to calculate. This is the case. At this point P, this is the direction of velocity 5 meter per second. When it complete half revolution, this will be the direction of velocity here. But you know, the direction of the velocity gets changed when it reaches at point Q. Then what will be the change in velocity? Change in velocity, suppose this is V1, this is V2. So change in velocity, delta V is equal to V2 minus V1. So minus 5, that is minus 10. Time taken to move from P to Q. Time taken by the particle to move from P to Q can easily calculated, because this distance PQ, that is the half of the circumference of this circular path. So time is equal to pi r upon velocity v. So pi into r5 upon velocity is also 5. So t is equal to pi. Now you can easily calculate acceleration. A is equal to delta v upon delta t. So this is our delta t actually. Delta t is equal to pi. So A is equal to minus 10 upon pi meter per second square. But minus sign is not given in any option. Therefore, our D option is correct. Next question, question number 6. This is important question. Here you have to find out Which statement is incorrect? Which of the statement is incorrect? Some of statements are given. First option is uniform circular motion is uniformly accelerated motion. B part, acceleration in uniform circular motion is always towards the center. So second option is correct, because in uniform circular motion there is always centripetal acceleration, and this centripetal acceleration is directed towards the center, no doubt. So this is the correct. Now C, in circular motion dot product of V and omega is always 0. So you first of all you try to find the angle between V, that is linear velocity, and angular velocity. As we know, the direction of linear velocity in the circular motion is always along the tangent drawn at any point of the circular path, and this tangent will be in the plane of circular path. So this is the direction of V. And omega is always perpendicular to the plane contained by circular path. It may be outward or inward as per the sense of rotation. Therefore, angle between omega and V, angle between omega and V theta is equal to always 90 degree. V lies in the plane of circular path, and omega lies perpendicular to the plane contained by the circular path, inward or outward. Therefore, dot product V dot omega is equal to V omega cos 90 degree. Cos 90 degree is equal to 0. Therefore, dot product of linear velocity and angular velocity will always be 0. In fourth option, in any curvilinear path, average speed and average velocity are never equal. This option is also correct, because if you try to find out the relation between distance and displacement in the case of circular motion, for example, suppose particle is here. When it reaches at point Q, the distance traveled is equal to arc of length PQ, and displacement is PQ, that is the direct distance between point P and Q, this distance. This is the displacement, and this is the distance. So in this way, if you take any point, 2 points on the circular path, and try to find out the distance and the displacement, they never be equal. Here also PQ, arc PQ is not equal to PQ straight length. It means average speed and average velocity will not be equal in any case. The average speed is equal to distance upon time, and average velocity is equal to displacement upon time. When the distance and displacement are different, therefore the average speed and average velocity will remain different. Now, first option, if we remove this word here, then A statement become true. Otherwise it is wrong, because uniform circular motion is accelerated motion, no doubt, because direction of acceleration keep on changing. Acceleration is centripetal acceleration. So when particle perform uniform circular motion, it has only centripetal acceleration, which is directed toward the center. This is the direction of centripetal acceleration when particle is at point P. When it reaches at point Q, again the direction of centripetal acceleration is towards center. When it is at point R, the acceleration is centripetal acceleration is directed towards the center. but you can see the direction of acceleration, centripetal acceleration, is changing continuously. From figure you can able to understand this situation. So here the acceleration is not uniform because direction of acceleration is changing. When we say uniform acceleration, it means direction as well as magnitude must remain constant, same. Here magnitude is constant because it is the case of uniform circular motion. In uniform circular motion, magnitude of the centripetal acceleration remains constant, but direction is changing. At point P, it is towards left. At point Q, it is towards downward. And at point R, it is towards right. So in this way, the direction of the centripetal acceleration keep on changing. That is why it is not the case of uniformly accelerated motion. It is only the case of accelerated motion. So uniform circular motion is the case of accelerated motion, not the uniformly accelerated motion. In uniformly accelerated motion, the magnitude as well as direction must remain constant. Next, a particle is moving in a curved path with constant speed. Speed is constant. When speed is constant means magnitude of velocity is constant. So which of the following quantities may remain constant? Acceleration. Acceleration is a vector quantity. Because in circular motion, the direction of velocity is changing, therefore the direction of acceleration is also changing. As I have observed in the previous question, the direction of centripetal acceleration keep on changing. Therefore, acceleration cannot be taken constant. Similarly, velocity cannot be taken as constant because direction of velocity is changing. So this option cannot be taken correct. But third option, the magnitude of acceleration is constant because the particle is moving with a constant speed. Speed is constant, it means this is the case of uniform circular motion, and in uniform circular motion, magnitude of centripetal acceleration remains constant. Next, question number 8. The ratio of angular speed of a second hand to hour hand of a watch is angular speed. You know formula for angular speed for second hand and hour hand. So omega angular speed for second hand is equal to 2 pi upon t. This second hand of a watch takes 60 seconds to complete one revolution. Therefore, 2 pi upon 60 is the angular speed of the second hand. Angular speed of the hour hand is equal to 2 pi upon time taken to complete one revolution by the hour hand, that is 12 hours. This 12 hours is converted into minute and then it is converted into second. So this is the angular speed of the hour hand. Now ratio Ws upon Wh is equal to 2 pi upon 60 upon 2 pi upon 12 into 60 into 60. So this is 2 pi upon 60 into 12 into 60 into 60 upon 2 pi. So 60 cancel out, 2 pi cancel out. This is 720 ratio 1. This is our correct option. Next question. 9th question. The length of the second hand of clock is 10 centimeter. It means radius is given 10 centimeter. Speed of the tip of the hands of the clock. So in this question, we can easily calculate angular speed of the second hand. Angular speed omega is equal to 2 pi upon t. Time taken by the second hand to complete one revolution is 60 seconds, so it is 2 pi upon 60. And we also know that the relation between speed, that is linear speed, and angular speed, v is equal to r omega. R is given 10 into omega 2 pi upon 60. So this is 2 pi upon 6, 2 into 3.14 upon 6. This is 6.28 upon 6. So this is coming out nearly 1.05 approximately. So it is approximately equal to 1 centimeter per second. So our D option is correct. Next question, question number 10. A particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, then the magnitude of corresponding linear displacement will be. Suppose the particle is moving along the circular path of radius r and it is at point P. When it reaches at point Q, it traces out angle theta. And what is the linear displacement? Linear displacement is PQ. PQ is the linear displacement when it moves from P to Q, and angular displacement theta is given. We have to calculate the value of PQ. This triangle OPQ is always isosceles triangle because OP is equal to OQ, OP is equal to OQ is equal to R. So this triangle will always be isosceles. When we draw a perpendicular from point O to PQ, then this ON perpendicular divides PQ into two equal parts. Because this is the case of isosceles triangle, so PN is equal to NQ is equal to X. So draw figure here, फिगर यहाँ बना लेते हैं और देखिएगा ये केस है, ये पॉइंट, दिस इज O, दिस इज P and this is N. This angle POQ is theta, therefore PON is equal to theta upon 2. This angle is theta by 2. ये क्या है? R है. तो sin theta by 2, sin theta by 2 is equal to, in this triangle, in triangle OPM, ये क्या है? ये 90 degree angle है. Because we have drawn a perpendicular from point O to PQ. So for this angle theta by 2, NP is the perpendicular. So NP upon OP. So sin theta by 2 is equal to NP upon R. So NP is equal to R sin theta by 2. And NP and NQ are equal. Therefore, PQ is equal to 2NP, 2R sin theta by 2. This is the linear displacement when the particle suffers angular displacement theta here. So PQ is equal to R sin theta by 2 is our correct option. Next question, question number 12. A rotating wheel changes angular speed from 1800 rpm to 3000 rpm in 20 seconds. Time is given, delta t 20 seconds given. And as I have told you, this is again the angular frequency, not the angular speed. It is, you can say, misprint, and it is generally in every book this type of the problem occurs. So this is frequency nu 1 is equal to 1800 rpm. Revolution per minute is equal to 1800 upon 60 revolution per second. 30 rps is the frequency. Corresponding एंगुलर स्पीड ओमेगा इज इक्वल टू 2 पाई न्यू 1 इज इक्वल टू 2 पाई इंटू 30 इज इक्वल टू 60 पाई रेडियन पर सेकेंड. From the unit you can easily recognize whether it is angular speed or angular frequency. Angular speed is given in radian per second, not in RPM or RPS. Similarly, nu2 is equal to 3000 RPM is equal to 3000 upon 60 RPS हो गया और ये आ जा रहा है 50 RPS. तो ओमेगा 2 इज इक्वल टू हो जाएगा 2 पाई न्यू 2 इज इक्वल टू 2 पाई इंटू 50 इक्वल टू 100 पाई रेडियन पर सेकेंड. नाउ फाइंड द एंगुलर एक्सेलरेशन. एंगुलर एक्सेलरेशन अल्फा इज इक्वल टू डेल्टा ओमेगा अपॉन डेल्टा टी. डेल्टा ओमेगा that is the omega 2 minus omega 1 upon delta t. Omega 2 minus omega 1 means 100 pi minus 60 pi upon 20. Time duration given 20 seconds. So this is 40 pi upon 20, that is 2 pi radian per second square. This is the value of angular acceleration. So be careful in the question, that is whether the given quantity is angular speed or angular frequency. Angular speed is always given in radian per second and angular frequency may be given in RPS or RPM. Next question. Question number 12. In the given figure, A is equal to 15 meter per second square. Represent the total acceleration of the particle moving in clockwise direction in a circle of radius 2.5 meter at a given instant of time and making angle 30 degree with OP. Speed of the particle is. So this is the case of non-uniform circular motion. In the case of non-uniform circular motion, the particle has centripetal acceleration as well as tangential acceleration. So the net acceleration is calculated by using this formula. A is equal to under root AT square plus AC square, and it is given 15 meter per second square. It is given A. ये की वैल्यू दी गई है 15 मीटर पर सेकेंड स्क्वायर, और ये जो एंगल जो ए बना रहा है ओपी के साथ वो दिया हुआ है 30. मतलब ये केस है, देखिएगा फिगर से, ये हमारा ओ पॉइंट है, ये पी पॉइंट है, जो एक्सेलरेशन है वो ऐसे दिया हुआ है और इसकी वैल्यू 15 मीटर पर सेकेंड स्क्वायर है, ये एंगल 30 गिवन है. अब हमें निकालना है स्पीड ऑफ द पार्टिकल. तो स्पीड पार्टिकल की और सेंट्रीपिटल एक्सेलरेशन का हमें रिलेशन मालूम है. क्या है कि ए सी इज इक्वल टू होता है वी स्क्वायर बाई आर. इस फार्मूले से हम स्पीड ऑफ पार्टिकल निकाल सकते हैं. तो हम पहले तो हमें इसका क्या निकालना पड़ेगा, यहाँ पर सेंट्रीपिटल एक्सेलरेशन की वैल्यू कितनी होगी, और वो निकाल सकते हैं कैसे, बाई फाइंडिंग द कंपोनेंट ऑफ दिस एक्सेलरेशन along OP. Component of A along OP will be the value of centripetal acceleration. तो AC इज इक्वल टू हो जाएगा A cos 30 डिग्री. A की वैल्यू है 15 और cos 30 डिग्री की वैल्यू होती है अंडर रूट 3/2. ये आ गया AC. अब इस फार्मूले का यूज कर लीजिए. V इज इक्वल टू हो जाएगा अंडर रूट AC इंटू R. AC की वैल्यू मालूम हो गई हमें 15 अंडर रूट 3/2 इंटू R. R दिया गया है 2.5. जब हम इसको सॉल्व करेंगे, रूट 3 की वैल्यू रखें, डिवाइड करें 2 से और फिर जो है रूट निकालें, तो वो देखिएगा इतना वैल्यू आती है 7.5 मीटर पर सेकेंड. ये जो है स्पीड पार्टिकल की निकल जाएगी. तो ये जो केस था वो नॉन यूनिफॉर्म सर्कुलर मोशन का था. नेक्स्ट क्वेश्चन देखिएगा. This is also one of the important question. Here, particle is moving in a circle of radius r centered at O with constant speed v. The change in the velocity in moving from A to B is, हमें चेंज इन वेलोसिटी पता करना है जब पार्टिकल इस पॉइंट से बी पॉइंट तक चेंज हो जा रहा है ऑन द सर्कुलर पाथ। ए से बी मूव किया तो जो एंगल बना ए ओ बी वो 40 डिग्री गिवन है। हमें पता करना है क्या, चेंज इन वेलोसिटी, वेलोसिटी में कितना चेंज होगा। तो ये हम कैसे निकाल सकते हैं, बाय अप्लाइंग द ट्रायंगल्स लॉ ऑफ वेक्टर एडिशन। वो कैसे, देखिए सपोज यहाँ पर क्या है कि ए पॉइंट पर जो वेलोसिटी है वो सपोज कर लेते हैं वी ए है और बी पॉइंट पर वेलोसिटी वी बी है, ये वेक्टर वेलोसिटी है ना। अब यहाँ पर है क्या कि मैग्नीट्यूड ऑफ वी ए इज इक्वल टू मैग्नीट्यूड ऑफ वी बी इज इक्वल टू क्या है वी है। मैग्नीट्यूड तो सेम है, मतलब इसका मैग्नीट्यूड भी वी है और इसका भी मैग्नीट्यूड वी है, लेकिन वेक्टर वाइज वो डिफरेंट है। तो चेंज इन वेलोसिटी कैसे निकालेंगे, हम ये फिगर इधर बनाते हैं, मतलब जो वेक्टर हमारा वी ए है उसके पैरेलल और इक्वल एक दूसरा वेक्टर ड्रॉ कर लेते हैं। यहाँ पर ये हमारा वेक्टर हो गया, समझो बी, ये ही इसको रहने देते हैं। और ये बी ए मैंने जो ड्रॉ किया है, मान लीजिए ये पॉइंट ओ है, ऊपर ओ न लेकर के कुछ और ले लेते हैं पॉइंट, उसे कंफ्यूजन हो सकता है। यहाँ पर पॉइंट मैंने पी ले लिया, तो पी एक्स पी आर जो हमने वेक्टर ड्रॉ किया है वो क्या है, बी ए के इक्वल और पैरेलल है। बी ए क्या है, वेलोसिटी ऑफ द पार्टिकल एट पॉइंट ए, उसके पैरेलल और इक्वल हमने एक वेक्टर ड्रॉ किया पी आर। अब दूसरा जो वेलोसिटी वेक्टर है वो वी वी है, उसके पैरेलल और इक्वल एक दूसरा वेक्टर यहीं पे ड्रॉ कर देते हैं। ये जो हमने ड्रॉ किया है पी क्यू वेक्टर जो ड्रॉ किया है वो इस बी बी के इक्वल और पैरेलल है। अब हमें निकालना है चेंज इन वेलोसिटी, और ये एंगल गिवन है 40 डिग्री गिवन है। जो एंगल यहां पर बन रहा वही एंगल बी ए और बी बी में भी होगा। तो चेंज इन वेलोसिटी कैसे निकालेंगे, डेल्टा वी इज इक्वल टू हो जाएगा फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी वेक्टर। इसको हम ऐसे लिख सकते हैं डेल्टा वी प्लस माइनस डेल्टा ई, मतलब हम इस वी ए का निगेटिव वेक्टर यहां पर बी वी में ऐड कर दें तो जो रिजल्ट आएगा वही चेंज इन वेलोसिटी होगा। तो बी ए का निगेटिव वेक्टर हमें इस तरह बनाना पड़ेगा, ये हो गया हमारा माइनस बी ए। अब हम इसको ज्वाइन कर देते हैं, ये हमारा हो गया डेल्टा वी, दैट इज चेंज इन वेलोसिटी, जो कि हमें निकालना है। अब ये जो एंगल हुआ वो हो गया 180 माइनस 40 डिग्री, एंगल बिटवीन बी वी एंड माइनस बी ए। अब यहां पर ट्रायंगल्स लॉ वेक्टर लगा देते हैं और ट्रायंगल लेंगे पी क्यू एस। इन ट्रायंगल पी क्यू एस, इन ट्रायंगल पी क्यू एस, देखिएगा ट्रायंगल्स लॉ वेक्टर एडिशन के अकॉर्डिंग जो डेल्टा वी का मैग्नीट्यूड होगा वो क्या होगा, स्क्वायर ऑफ दिस, स्क्वायर ऑफ मैग्नीट्यूड ऑफ दिस वेक्टर प्लस स्क्वायर ऑफ मैग्नीट्यूड ऑफ दिस वेक्टर इनटू 2 इंटू, ये फार्मूला होता है ना रिजल्टेंट का, आर इज इक्वल टू होता है अंडर रूट ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab कॉस थीटा, ये है फार्मूला रिजल्टेंट निकालने का। तो हम यहाँ पर किसका रिजल्टेंट निकाल रहे हैं, देखिए पी एस वेक्टर जो कि माइनस बी ए है और पी बी वेक्टर, इन दोनों का जो है रिजल्टेंट जो है वो एस क्यू है, जो कि हमने डेल्टा बी से रिप्रेजेंट कर रखा है। तो ये फार्मूला लगा दीजिए, है ना। और यहाँ पर ये भी लीजिए कि इसका जो बी ए का मैग्नीट्यूड है वो बी बी के मैग्नीट्यूड के इक्वल है। तो इस तरह से डेल्टा वी का मैग्नीट्यूड हो जाएगा अंडर रूट, देखिएगा वी स्क्वायर बी ए का मैग्नीट्यूड का स्क्वायर प्लस वी के मैग्नीट्यूड का स्क्वायर प्लस 2b इंटू वी, दोनों भी ही है, और साथ में क्या आएगा कॉस ऑफ दिस एंगल, इस एंगल का कॉस, तो यहाँ पर क्या आएगा कॉस 180 माइनस 40 डिग्री। ये फिर से यहाँ पर लिख लेते हैं ठीक से। देखिए यहाँ पर आया है वी स्क्वायर प्लस 2v स्क्वायर कॉस 180 माइनस 40 डिग्री। तो इसकी वैल्यू हो जाएगी देखिएगा 2v स्क्वायर प्लस 2v स्क्वायर, और ये देखिए कॉस 180 माइनस 40 जो है दैट इज इक्वल टू माइनस कॉस 40, तो यहां पर माइनस साइन आ जाएगा। ये साइन क्या होगा माइनस कॉस 40 डिग्री। अब यहां पर रूट के अंदर हम कॉमन ले सकते हैं क्या, 2b कॉमन ले लीजिए, 2b स्क्वायर, तो हो जाएगा 1 माइनस कॉस 40 डिग्री। तो 1 माइनस कॉस 40 डिग्री इज इक्वल टू होता है 2 साइन स्क्वायर 40/2, तो ये हो जाएगा अंडर रूट 2v स्क्वायर इंटू 2 साइन स्क्वायर 40/2 यानी 20 डिग्री। ट्रिग्नोमेट्रिक रिलेशन अप्लाई कर दिया। तो इस तरह से ये हमारा हो गया देखिएगा 4v स्क्वायर साइन स्क्वायर 20 डिग्री। अब इसका हम रूट निकालेंगे तो हमें रिजल्ट मिलेगा 2v साइन 20 डिग्री। ये आया क्या है, मैग्नीट्यूड ऑफ चेंज इन वेलोसिटी, जो कि हमें पता करना था चेंज इन वेलोसिटी। तो चेंज इन वेलोसिटी आ गया 2v साइन 20 डिग्री। तो इस तरह से हम ये रिलेशन मतलब सेकेंड ऑप्शन जो है हमारा करेक्ट हो जाता है। तो जब भी कभी हमें किसी क्वेश्चन में सर्कुलर मोशन के केस में चेंज इन वेलोसिटी निकालना है तो हम इसी तरह से निकालेंगे, और थोड़ी प्रैक्टिस और कर लेंगे इसी टाइप के क्वेश्चंस की, तो आपका सर्कुलर मोशन परफेक्टली जो है प्रिपेयर हो जाएगा।